We're going to solve the following logarithmic equations using the definition of a logarithm, which is y equals log to the base b of x if and only if b to the y equals x. Notice b represents base. Y is the corresponding exponent and x is the result. So for our first one, log to the base 3 of x equals 2. Now we'll rewrite that in exponential form, so this implies that 3 squared equals, and the result is x. And so 3 squared is 9, so x equals 9, and we're done with that one. Well, we have the equation log to the base 2 of the quantity 2x plus 1 equals 3. So we'll employ the definition of a logarithm and rewrite this equation in its exponential form. And so the base is 2, the exponent's 3, the result is 2x plus 1. Well, 2x plus 1 equals, and if you cube 2, you get an 8. 2 cubed is 8. Now we'll subtract 1 from both sides, so we have 2x equals 8 minus 1 is 7. Now we'll divide both sides by 2, so x equals 7 over 2, and we have it. Well, here we have log to the base x of 1/8 equals 3, so we'll employ the definition of a logarithm and rewrite this thing in terms of its exponential form. And so we have the base x raised to the 3rd power equals 1 over 8. And it turns out this is a perfect cube. So x to the 3rd power equals 1/2 cubed. If we cube 1, we get 1. If we cube 2, we get 8. So taking the cube root of both sides, we have x equals 1/2. Solved another one. Finally, we have the natural log of e to the negative 2x equals 8. And before we go on, keep in mind that the natural log of x equals log to the base e of x. So this is mathematical shorthand. And so what's the base here? It's e. So now we'll employ the definition of a logarithm and rewrite this thing in exponential form, and we have e, the base e, which is implied, raised to the 8th power equals, and the result is e to the negative 2x. So since the bases are identical, we can equate exponents. So 8 equals negative 2x. Now, if we divide through by negative 2, we'll have x equals, and 8 divided by negative 2 is negative 4. And we're done.